Why certain metals burst into flames or even explode when they touch water? Why does a simple shiny piece of metal like sodium, which looks harmless at first glance, suddenly react so violently the moment it meets just a drop of water? The answer lies in one of the most fascinating families of the periodic table, the alkali metals. These elements sit in Group 1 and include lithium, sodium, potassium, rubidium, cesium, and the rare francium. They are not ordinary metals. Instead, they are soft, highly reactive, and play a major role in industries, technology, and even life processes within our bodies. At first glance, they may look like harmless silvery blocks, but their inner atomic structure makes them some of the most explosive and chemically exciting elements we know. The reason alkali metals behave this way is hidden in their electronic structure. All of them share a simple configuration. Their outermost shell contains just one valence electron. This single electron is their strength as well as their weakness. Because it is so loosely held by the nucleus, it can be lost very easily, turning the atom into a positively charged ion with a +1 charge. Once that electron is gone, the atom becomes stable, which is why these metals react so quickly and so strongly. As we move down the group from lithium to francium, the atoms become larger and the distance between the nucleus and that outer electron increases. This means the attraction between the nucleus and the electron weakens, making it even easier for the atom to let go of its electron. This explains why lithium is the least reactive, sodium is more reactive, potassium is stronger still, and by the time we reach rubidium and cesium, their reaction with water is so violent that it can shatter glass containers. Physically, alkali metals look very different from the hard, heavy metals people are familiar with. Instead of being tough, they are so soft that you can slice sodium or potassium with an ordinary kitchen knife. Their density is also low, and some of them, like sodium and potassium, are lighter than water, so they float. They're melting and boiling. Points are surprisingly low compared to most metals, with sodium melting at only 98 degrees Oxy, a temperature lower than the boiling point of water. Their bright silvery shine, however, does not last long. The moment they are exposed to air, they react with oxygen and quickly develop a dull oxide coating. Another interesting physical property of these metals is their flame test colors. Lithium gives a crimson-red flame, sodium burns with a brilliant yellow, potassium gives a lilac flame, rubidium produces a red-violet, and cesium shows a deep blue-violet. These flame colors occur because the single outer electron absorbs heat, jumps to a higher energy level, and then releases visible light when it falls back. This simple but beautiful property makes them easy to identify in laboratories. Chemically, alkali metals are famous for their dramatic reactions. Their reaction with water is perhaps the most iconic demonstration in chemistry. The general reaction can be summarized simply. Metal plus water produces a metal hydroxide and hydrogen gas. Lithium reacts calmly, fizzing gently on the water surface. Sodium reacts faster, producing enough heat to melt into a shiny ball that skates across the surface. Potassium reacts even more violently, with enough energy to ignite the hydrogen gas and produce a lilac flame. Rubidium and cesium go beyond violent. Their reaction is explosive, with bursts powerful enough to smash the container. Francium, though too rare and radioactive to observe directly, would theoretically be the most explosive of them all. With oxygen, the type of oxide formed depends on the size of the atom. Lithium forms a simple oxide, sodium prefers to form peroxide, while potassium, rubidium, and cesium tend to form superoxides. Superoxides are unusual compounds that release oxygen and are actually used in breathing equipment such as in submarines and spacecraft. With halogens like chlorine, all alkali metals form simple crystalline salts, such as sodium chloride and potassium chloride, both of which dissolve easily in water and are essential in everyday life. With hydrogen, they form ionic compounds called hydrides, containing hydrogen as H ions, which are useful in specialized industrial chemistry. Their compounds are incredibly important. Sodium chloride is ordinary table salt, necessary for nerve function and food preservation. Sodium carbonate, or washing soda, is used in glass making and cleaning. Sodium bicarbonate, or baking soda, is essential in baking, medicine, and cleaning. Sodium hydroxide, also called caustic soda, is one of the strongest bases known and is used in soap making, textiles, and paper production. Potassium hydroxide, another strong base, is widely used in fertilizers and alkaline batteries. Potassium nitrate, also known as saltpeter, has been historically important in making gunpowder. Cesium has a very special use in atomic clocks, which measure time so accurately that they only lose a second in millions of years, while rubidium is used in research and special electronics. Lithium, the lightest and most unique member, has revolutionized modern technology through lithium-ion batteries, which power smartphones, laptops, and electric cars. Lithium is also used in medicines to treat certain mental health conditions and in systems that absorb carbon dioxide, making it useful in spacecraft and submarines. Lithium is also special because it behaves differently from the rest, showing what chemists call a diagonal relationship with magnesium. For example, lithium forms less soluble salts, such as lithium carbonate, and lithium fluoride, much like magnesium. Lithium can also form a nitride directly with nitrogen, something that the other alkali metals cannot do. These unusual behaviors make lithium stand apart from the rest of the group and give it unique applications. Despite their usefulness, alkali metals are dangerous if not handled with care. Because they react instantly with oxygen and moisture, they are never stored in open air. Instead, they are kept under oil to stop them from reacting. Even a small piece of sodium or potassium can start a fire if it comes into contact with water, and the heavier metals like rubidium and cesium can cause explosions. In the event of a fire, water must never be used to put it out, because it only makes the reaction worse. Instead, dry sand or special Class D fire extinguishers are required. When working with these metals in labs, safety precautions like wearing goggles, gloves, and using protective shields are absolutely necessary. In conclusion, alkali metals may appear to be simple, shiny, silver-colored elements, but they are among the most reactive and fascinating substances in the periodic table. Their chemistry revolves around a single outer electron, yet that single electron controls everything, from their softness to their violent reactions, to their role in modern industry. They are metals that burn with color, fizz with water, and form compounds that shape human civilization. From the salt on your table to the batteries that drive electric vehicles, alkali metals connect the beauty of chemistry to the reality of daily life. They remind us that the smallest building blocks of nature hold the power to transform the modern world. So, the next time you see the periodic table, don't just look at those shiny boxes as boring symbols. Think of the alkali metals, the group that can burst into flames with just a drop of water, yet also give us the salt we eat every day and the batteries that power our modern lives. They are living proof that chemistry is full of surprises, where something as small as a single electron can make the difference between calm stability and explosive energy. If you enjoyed learning about these fascinating elements, make sure to stay curious, keep exploring, and dive deeper into the wonders of science. Thanks for watching, and I'll see you in the next guide to the secrets of the periodic table.